So here are some tips that the book provides for debugging. So everyone is a suspect is their first one, except for Python, right? The idea here is that you might think that Python is doing something wrong, but chances are is that it's more likely you're doing something wrong or I messed up somewhere. It's, a very well used language, so it's probably not the problem. But everything is a suspect that you write. Everything. And if you think your code is doing something, double check it, even if you're pretty sure about it. I emphasize this to everybody. I'm going to digress for a second. This is my teaching philosophy thing. It's very interesting. I'll send it to, or at least I thought it was very interesting. I'll send it to you if you're curious, but I do keep it posted publicly. But I bring it up here because of this paragraph over here, which are the difficulties are the challenges of teaching computer science to students. So I'm going to read this out loud. The third is that you are your own worst enemy when you program. A single misplaced brace or missing equal sign can cause hours of mind-numbingly agonizing debugging. Even the most experienced programmer is not immune to this. Everyone makes mistakes, especially when we read what we want to read as opposed to what's there. Take the previous sentence, for example. So, in this sentence, what did I mess up? I have an intentional grammatical error in a proper document that I've submitted for yearly reviews and stuff. It's a very good example, though, of this. This is your mind sees the two does, but you read it to yourself, so you see one. Your mind is very good with basically creating these heuristics to make its job easier. It really wants to make your life easier, and so it basically does things that can sometimes be irritating. Now, take this into account over multiple lines of code, and you get an idea of why this is difficult. Let's go ahead and see. I'm going to go ahead and basically I'm going to have to show you in Java because this is much more of a thing in Java. But this is an excellent example of what happens. A lot of times we have something called a nested for loop in Java, and it looks something like this. Yes, I know it's Python, and I know how to get started in it. Don't worry. So, first I have to configure the font. Give me a second to hit my settings. Edit. Selection. Let's go ahead. Preferences. There we go. Settings. Font size 24. There we go. So here's what a for loop looks like in Java. Not really something you have to remember, but it's very easy to illustrate a mistake here. For int I is equal to 0, I is less than, let's say, limit. Let's go ahead and say 10, whatever. I plus plus. And then a nested for loop would look something like this. For int j is equal to 0, j is less than 10, j plus plus. And this is very common, and I've written it correctly here. But basically whatever, and effectively what would happen here is that basically do thing would be called a grand total of 100 times. The don't worry about why for right now. What I'm going to show you is an example of a very common mistake that happens, right? A common mistake here is that you can see is that normally you get so into the habit of writing int I is equal to 0, I is less than 10, I plus plus. Okay? You get very much into the habit of it. And I and j, they look stinking similar. So a very common habit is to do this. And that will make this program run forever. Why? Not important right now, but that will make it run forever. Or you might do something like this, in which case it will run forever. Or you might have something like this, in which case it doesn't run nearly as many times as you think it should. These are the kind of things where basically, I'll go over to a student and I'll see it and I check that and I see, oh, you've got a J where you're supposed to be, where you've got an I. Now, inevitably, this makes the student feel like, for want of a better word, a moron. The student is not a moron. They feel like they are. And that is part of what makes computer science. And that is what I think, more than anything else, makes computer science difficult. Not a mathematical knowledge. You can learn that when you want, It doesn't really require too much complex math to get started in it. And even for the endgame stuff, and that's not too. The math isn't too difficult. For the logic, you can learn that. That's a skill. It's just something you just need to practice. Same with the programming. But this kind of stuff, where you make a mistake and you bring it over to your professor and you go, I banged my head against the wall for 3 hours last night trying to fix this. Can you please help me? And he goes, oh, yeah, I immediately see it. And he fixes, and he goes, oh, I see the problem right here. J. You had an I where you're supposed to have a J. Student feels demoralized. He feels really bad. So here's the thing. This is a mistake that happens to everyone. The difference between me and the student is that I made this mistake a whole lot more times than him. So I immediately know, I have immediately this mental checklist of what I need to check. Kind of go, okay, so he messed up here. Not only that, but I've seen about 12 of his peers do exactly the same, come to me with exactly the same problem. That doesn't mean 12 people, that only 12 people out of 100 messed up. Doesn't mean that only 7 to 10% of the class messed up on that. That's just the people who asked for help. Guarantee you tons of people made that mistake. There is this problem when you're learning computer science that basically is that you compare yourself to everybody else and you don't actually have an accurate heuristic for how everybody else is doing. So you just feel demoralized. And, you make these small mistakes and then and a lot of times you find them on your own. And you feel like you wasted a lot of time. It hurts. What I want to say, though, is that you are not alone in this. To quote Yoda, failure, the greatest teacher is. The only way you're going to get better at debugging and fixing the mistakes is by making these mistakes and figuring out how you made them. This is why I'm not afraid to live code, and why I do my best not to edit out any mistakes that I do make. Sometimes I will edit out if there's a long process for me to fix it, or I'll speed it up, or I'll make cuts and jump to it. But if I make mistakes while coding, I fix them and show you that I make mistakes too. Because if you think that I am perfect, and that all these hotshot programmers who do everything are perfect and know how things work, oh boy, that is not at all how it works. If anything, I would definitely look up, especially since you're in college, something called imposter syndrome, which is very common for college students to have. especially the higher up you go. Mistakes are common. Don't feel bad because you make them. Don't feel bad if you make them multiple times. Because we all have to start somewhere. Making mistakes is the only way to learn. Right? Or as they say, basically, you learn by doing trial and error. In computer science, it's primarily error. The other things that you should, so definitely check your assumptions here. That ties into that. And then find clues. And you'll find out that basically that error messages and print statements are what's going to help you with this. So we're going to go into those in the next videos. If you feel demoralized, please come back to this video and at the very least watch this part. It's okay. Take a deep breath and never be afraid to ask for help. I'm here for you. And I'm here to help you get through this, and I'm not going to think less of you for any mistake you make. Right? You're still learning, and the sooner you ask for help, the more I'll respect you.